Hello everybody and welcome to this video on how to create a project in STM32CubeIDE 2.0. So this new CubeIDE 2.0 version has brought about some big changes. One is you no longer have to log in to use it, and the other big change is they've taken out CubeMX from CubeIDE. And so they talk about why they separated them. The big reason here being that people didn't want to use CubeIDE to build their projects. They wanted to use VS Code, and they felt that integrating CubeMX and CubeIDE was never truly appreciated by the users. So they've decided to separate them, which personally I appreciate. The more and more I use it, the more I like it. So I can say I do like this new change. One thing to note here, CubeMX is going to initialize your code. It's going to generate your code. If you use CubeIDE before, older versions, maybe the 1.x versions, those all have CubeMX built in, and you've probably used it. Actually, you've definitely used it. Whenever you said create a new project in CubeIDE, you can see up here we're in IDE, and I know we're in version 1.7 just because of the name of this workspace. But if we're in version 1.7, when we create a new project, the first thing we do is we bring up this configuration menu in CubeMX. And so we would use CubeMX to create a new project. Um, Now we have them separated, so we have CubeMX as its own standalone tool, and we go through and we generate code for our specific chip, for our specific pinout, for what we want to do, and we will open that in CubeIDE if we choose, or another IDE. But we get to generate code for a specific project structure. And so in this, we're going to say, hey, we want to generate a CubeIDE project. So I'm going to quickly go over that. Uh, Today, I have my little STM32L4 here. I'm going to go ahead and just plug that guy in. So you can see it brings up this page. You can drag and drop files here and put them in the flash memory of the STM. I'm not going to do that, so I'm just going to run it through the IDE. To get started here, we're going to open CubeMX. And so I want to make a simple project here where if I press this blue button right here, I want this LED right here, this green LED to light up. And so I'm going to go ahead, let's see. I'm going to go ahead and turn that off for now. So we're in here in CubeMX, we just booted up. What we're going to do is we're going to say, I want to make a new project. I need to start my project from the MCU. So yeah, we have an MCU, a specific MCU, and that's kind of our starting point. We want to configure that MCU for properly for our project. So we're going to select, here we have the STM32L476RGT6. Okay, so I'm going to click on that one. You can see I have it starred, I have it favorited, so I can star that. And in here, that's all I need to do. So I'm just going to say start project. It's going to bring up a new project, and now we're going to go configure all of the config for the IO as well as the clock configuration, and then where we want to put this project. So to start with, I want to look at the schematic for the STM. I can see that blue button I want to press. Well, that's hooked up with a pull-up resistor. So note this is active low. If I don't press the button, this is going to be a 1 here at PC13. That's the input I'm looking at. At PC13, it's going to be a 1 if I don't press the button, and if I press the button, it's going to be a 0. And so again, this button, what it's telling you is it's active low. Let's just remember that, but PC13 is the pin we're using. If we scroll down a bit in the schematic, we can see we have this green LED, and that's going to be hooked up to PA5. And so we're going to hook up PA5 as our GPIO output, and PC13 is our GPIO input. And remember, folks, no need to make pull up or pull down on this guy because we already have internal pull up here. So no need to configure those GPIO. We can do that for other projects, but for this one, not going to. Okay, so we'll make PA5 GPIO output. So I found that there, that's PA5. I know kind of generally where they are, but if you don't, just zoom in, you'll be able to see it. Okay, so PC13, we're going to make it a GPIO input. And again, if I wanted to make these pull up or pull down, or maybe I wanted to make this output open drain configuration, the way I could do that is I could go to System Core, go to GPIO. I could drag this configuration window up to see it, and I could drag this to the right to be able to see it. And then I could change the GPIO mode, or I could at least click on these and then be able to kind of scroll through these settings down here. So scroll through these settings, I can say the output speed, whether I want pull up, pull down, again, push, pull, open, drain, and same thing with our input pin. Again, there's no push, pull, open, drain for the input pin, but we do have the option to pull up and pull down configure it, so that's nice. But we're not going to do that for this project, so now we're just going to move on to the clock configuration window. So I'm going to go here to clock configuration. In here, we have a few crystal oscillating clocks. Right here, we have this LSI RC. LSI is low speed interface, MSI is medium speed interface, and HSI is high speed interface. So if you want to guess which one we're going to use, we're probably going to use the high speed interface most times because we want to be pushing that maximum clock frequency around 80 megahertz. So we're going to go here. We're going to multiply by 10, divide by 2. That's going to, do a little bit of filtering on our signal, and we're going to pass that through the PLL clock. So that's going to come out 80 megahertz. And note that all these different buses and timers are all going to be powered with 80 megahertz now. So that's going to be our configuration. If we scroll down, we can see that almost everything right here is 80 megahertz, but over here, we got to be careful. Our ADC is running at 64 megahertz. So if we wanted to run the ADC, just remember, it's not running at that 80 megahertz. So if you ever are confused or want to know what clock speed something's running at, make sure to go through and look at this clock configuration side of things. Okay, so we're done here. We're going to move on to the project manager. We're going to give this project a name. I'll call it LED button. And then I am going to leave all this. The only thing I want to do is I want to make sure that I change this toolchain/IDE to STM32CubeIDE. And yes, I want to generate under root. For some reason this disappeared, so what I'm going to do is uncheck and recheck that box. And if you look, that's where I'm going to put my LED button project, and that's exactly what I want to do. So I'm going to go ahead and say generate code, and it's going to generate. Sometimes it takes a while, sometimes it doesn't, depending on the library files, but we'll see. That was pretty quick. It says the code is successfully generated under, and this is correct if we look. That's exactly where we expected it, same place. And it says the project language is in C, which we wanted, so we're going to open the project. That's going to open STM32CubeIDE. So now we're going to open this, open the workspace, and this opens pretty quick now. Okay, and you can see this project has just been successfully imported into the workspace. So now we're going to go here. Here's our project. The way we open it is we drop down. If we want to go to our main file, we go to core, source, we go to main. If we want to edit our IOC file, we could double click this right here, and this will open CubeMX, but we'll leave that alone for now. Again, we have our includes, our main, we have some other includes that we definitely need, but here are kind of the user includes, and then our main right here. So we have this generated code. I'm not going to talk much about this code generation. What I will say though is that make sure you put your code between user code begin and user code end. That is very helpful. And just make sure that you don't accidentally put your code here after a user code end. Make sure you put it after a user code begin. Okay? Let's see. Yeah, we include main.h. We have some private includes. We have these function prototypes for the clock config and the GPIO init. Gee, I wonder what those do. This one is going to configure the clock to be 80 megahertz. this one is going to configure our 2 GPIO pins. And if we scroll down, we know that's true. We see we have our oscillating init structure, and we're going to be setting stuff in it to get that 80 megahertz clock. For our GPIO init, we have our 2 pins, PC13 and PA5, and PC13 is again our input, so you can see GPIO mode input. It's pin 13 for block C, and PA5 is going to be pin 5 for block A. Okay, and so again, we have these registers associated with each block. We're going to be able to set, reset, or access the input from a register. Okay, so this is how we're going to do it. Remember, I said don't put your code after a user code end. Put your code after a user code begin. So I'm going to put my code right here, and so I'm going to say active low button. So I'm going to say if, and the condition I'm checking here is I want to check that the GPIO C, so the input PC13, the input data register, and again I want to mask this, so I'm only looking at the one pin that I'm talking about. Again, I didn't configure any other GPIO C pins for this project. I only want to look at pin 13. So if GPIO C IDR and GPIO pin 13, this is our mask, which is pretty handy. If the input data and GPIO pin 13 equals 0, so if that's how we know that the button's pressed, because it's active low button. So if that, we're going to do GPIO A, and we're going to do the bit. So we have two options, the bit reset register or the bit set and reset register. So if we use BSRR, that's what we want to use. We'll use BSR, the bit set and reset register. We'll say GPIO bit set and reset register equals, and for this design again, we're just going to shift into 5 because we're not using any of the other pins. So we're going to save that, and then we'll say else. So if the button's not pressed, so we'll say if pressed, and else not pressed, GPIO A, and we're going to use the BRR here, equals 1, shift in 5. And again, so this bit reset register, what it's going to do is if you put a 1 in a place, it's going to go ahead and clear that place where you put a 1. So the set and reset register, you put a 1 or you put a 0 in to either set or reset it. For this one, you're going to put a 1 in where you want to reset it. So that's how we're going to do it. To run this code now, again, I have my board plugged in, so I have my board plugged in. I can unplug it, replug it, and show you again. So I'm going to unplug it, and then I'm going to show you if I run it, it's going to say building project. You can see 0 errors, 0 warnings, and it's going to say launch configuration properties. We're just going to click OK. I'm okay with the default settings here. Okay, waiting for debugger. You can see it's flashing green and red down here. And you can, if you go back through this log, it created a log in this output, but it basically connected, and then it flashed the section of memory it needed to for this program. Okay, so let's test if our circuit worked. Again, I want to press this blue button, and I want to see the LED if I press the blue button. There we go. Let's go. So if we press this blue button, we see that LED output. If we let go, we see it turn off. So just a little starter project for CubeIDE. just to get you guys going, I wanted to just show overall how to get a project set up. So again, you're going to generate your code with CubeMX, and then you're going to edit it and run it in CubeIDE. And so that's a basic workflow. Thank you guys for watching the video, and please like and subscribe. Thank you.